This is called the discriminant. The discriminant comes from a part of the quadratic formula. It's the part underneath the square root. B squared minus 4ac. With the discriminant tells you something special. It tells you what the solutions to the problem will look like. So it's kind of a trick that you can use to figure out what the solutions look like before you ever solve the problem. So b squared has 3 possible cases that can happen with the discriminant. The first one is b squared when b squared minus 4ac is greater than 0, or when it's positive. The second one is when b squared is minus 4ac is equal to 0, or b squared minus 4ac is less than 0. Okay, here's our first example. You take a problem, you find a, b, and c, you put it into the discriminant. So this is the discriminant. Plug it in, I got 29. Okay, now here's the deal. Because 29 is positive, when your answer is positive, it means there are 2 real solutions. That's the part that we're worrying about. So that we know that our solutions, there are 2 real solutions. 29 will not simplify. Like if you tried to break the square root down, if you tried to break square root of 29 down with a factor tree, 29 is prime. And so if you get a prime number underneath the square root that won't simplify, it is called irrational. We haven't talked much about irrational numbers, but here's what they are. Irrational numbers have decimals that do not repeat or end. So what this means, when you look at the picture, this is the graph right here. When you look at the graph, it means that the place on the x-axis, it will not touch at a whole number, so it will touch the graph at a decimal. Here's example number 2. Here's a problem. Identify A, B, and C. Here's the formula. Here's your formula. Plug in A, B, and C, you get 25. Okay, because 25 is positive, there are 2 real solutions. This is part of your answer. This is part of your answer, square root of 25, or 25 is part of your answer, and that there are 2 real solutions is part of your answer to the discriminant when you're asked a question about the discriminant. But here's one more part. Since 25 can be simplified to plain old 5, the real solutions are rational. Rational numbers end or have decimals that repeat. So what this picture will look like is that it will cross at whole numbers. The graph. See these places right here? It will cross at whole numbers. In this case, it's -1 and 4. Here's our third case. Here's our problem. Identify A, B, C. Here's the formula for discriminant. Plug it in. When you solve the discriminant, you get 0. Here's what 0 means. 0 means that when the discriminant is 0, there is one real solution. Here's what it looks like in a picture. I factored this problem to show you. And then when you set factors equal to 0, you really get x equals 3 for your x-intercept, or where it touches the x-axis one time. Now this is a little weird, but the deal is sometimes people call it multiplicity 2, or this just repeats twice. Because you factored it and it had the same factor, or it's a perfect square, you only get one answer that touches the x-axis. Next example. Here's the problem. The formula, I plug it in. The discriminant equals negative 12. So this is what it would look like in the quadratic formula. Well, we know that when we have a problem like this, that we're going to have an I in our answer. This one would simplify actually to be 2I square root 3. When the discriminant is negative, then there are two imaginary solutions. What this means is that the graph will never touch the x-axis. So look at the graph. Here's the graph. The graph would look like this. The y-intercept is 7. The vertex is 2 and 3. The graph does not touch the x-axis. Remember, guys, this is the x-axis. All right. Hope you got that.